Hello, welcome. We are on lesson 2-5, which is on pages 24 and 25 in your workbook. This is our last section in the chapter. We have the beautiful Miss Lakin Puckett, the #1 math student from 2016, for our I can statement.
Hi, I'm Lakin Puckett, one of Miss Belcher's old students, and today we will be doing lesson 2-5. I can identify whether a linear equation with one variable has one, infinitely many, or no solutions.
Awesome. So the first thing we need to talk about is what the different solutions look like. There is a key concept box in your workbook notes, and I want you to look at the solutions column first. So that's the middle column. It says none, which is no solution, one, or infinitely many. Sometimes you may see infinitely many wrote as just infinite. Okay, so for no solutions, it's like A equals B. So for no solution, you're going to have different numbers, and they're going to equal another number. It doesn't matter if they're positive or negative. -6 equals 4, 2 equals 8, -11 equals -19. They're just not going to be equal. So there are blank values of the variable for which the equation is true. There are 0 or no values. We know that all these numbers are not the same. The next one is one solution. The equation is blank for exactly one value of the solution. So this is like an answer. So for one solution, we might have x equals 6, y equals 23, z equals -4. Positive or negative, it doesn't matter. And the last one on infinite, or infinitely many, this one's all values. Infinitely many is going to look the same on both sides. Now it might be the same with variables, like a equals a, or 4x equals 4x, or it might be the same with numbers. 12 equals 12. Whatever it may be, it's going to look the same. Now, if you look at the very beginning, like after you combine like terms or after you distribute an infinite, you may have the same value for both variable and number. And I'm just going to erase the bottom one so I can show you what an example of that would look like. Maybe you might have 6a plus 3 equals 3 plus 6a. Now they're not in the same order, however, 6a is the same on both sides and positive 3 is the same on both sides. So that's what your infinite solutions are going to look like. Here's our first example. We are going to solve this just like we did when we have variables on both sides. We want to usually try to move the smallest variable. So I'm going to subtract 4w. 6 minus 4 is 2w. I'm going to bring down my plus 3. Those have canceled and I have -1 over here. Minus the 3, it's a 2-step. Divide by 2. And w equals -2. Now what we're saying is this is going to make both sides true. So if I look at just the left side, 6 times negative 2 plus 3. Well, that's negative 12 plus 3, which is going to be negative 9. And then if I look at the right side, 4 times negative 2 minus 1, negative 8 minus 1 is also negative 9. So what you're essentially saying is these sides of the equation are equal, and negative 2 is what's going to make them the same. So this one is one solution. Let's look at another. Alright, number 1, example B. I have to distribute before I can evaluate each side here. So I'm going to bring down 6w plus 3. 6 times w is 6w. And 6 times 0.5 is 3. I can go farther than this if I need to, but I can look already and see that these sides are perfectly identical. So I know that this one is going to be infinite, or infinitely many. I don't have to go any further. If I subtracted 6w from the left, it would also cancel it on the right. Same thing with the 3's. Let's look at another example. Alright, on C, I have to distribute again. So I'm going to bring down 6w plus 3, and then I'm going to distribute. 6 times w is 6w, and 6 times negative 4 is negative 24. If I compare the sides of my equation, the variables are the same. Same number, same sign, same variable, and the numbers are different. 3 is not equal to negative 24. This one is no solution. Alright, there are some quick check problems for you. A, B, C, and D. I would like you to distribute, and I would like you to tell me why you have chosen if your answer is 1, infinitely many, or no solution. For example, if I looked back at C, I would just say same variable, different number. So let's recap our rules, things that you could use to say why you chose your solution. One solution, you get an answer. Infinite or infinitely many, they are identical or the same. They have the same variable. They have the same number. And no solution. It has the same variable. But it has different numbers. Alright, happy practicing. See you tomorrow.